बिस्मिल्लाहिर्रहमानिर्रहीम रब्बी ज़िदनी इल्मा। ऐ मेरे रब मेरे इल्म में इजाफ़ा फरमा, आमीन। अस्सलाम वालेकुम class, I am your physics teacher Iram. We are going to start unit number 11, Geometrical Optics today. Optics mainly deals with the light. In this chapter we have to discuss the behavior of light such as reflection, refraction and total internal reflection. And we will also discuss some optical instruments, the working principle of that instruments, and how light is used to cast the image of different substances, different objects in different instruments. So let's start with the first topic, reflection of light. Reflection of light can be defined as when light traveling in a certain medium falls on the surface of another medium, a part of it turns back in the same medium. This is called reflection of light. It means whenever the light is traveling in one medium and there is a second medium in front of that incident light, it will strike the medium and bounce back in the first medium with such that it obeys two laws. The laws of reflection are the incident ray, the reflected ray and the normal to the reflecting surface all lie in the same plane. Here you can see incident ray, reflected ray and normal. Incident ray means the ray which is traveling from one medium. Reflected ray means the bounced ray. When the incident ray strikes the surface of second medium, it reflects back in the same medium. That ray is called reflected ray. Normal is an imaginary line which is drawn perpendicularly to the surface of the second medium. And the second law of reflection is the angle of incidence is equal to the angle of reflection r. Here you can see in the figure that angle of incidence is present between the incident ray and the normal, and the angle of reflection is present between the normal and the reflected ray. These two angles will be same. You can also see this video. Here the incident ray is striking the surface of another medium such that it reflects back, and here is the normal, the imaginary line, so that angle of incidence is equal to angle of reflection. There are two types of reflection, regular reflection and irregular reflection. Irregular reflection can also be said as, it can be called diffused reflection. In regular reflection you can see that the incident rays are reflected back with obeying the laws of reflection such that the angle of incidence is equal to the angle of reflection. Why? Because the surface of the second medium is smooth. Here you can see in this example, plane mirror or any other surface that produces a reflected image. The reflection which is caused by the smooth surfaces is called regular reflection. In this case, a clear image is formed in the second medium, and in this type of reflection the laws of reflection are obeyed. In second type, you can see the angle between the incident rays and normals, means the angle of incidence and the angle of reflections are not equal. Why? Because the surface of the second medium is not smooth, it is irregular, so that the light rays do not obey the laws of reflection. This is like any surface that we can see but does not reflect an image. You can see the in the example, first figure is of smooth water surface. In this reflection, the regular in this type from smooth water surface, regular reflection takes place, and you can see a clear image in the water. The image of mountain is clear in the water below. In the second figure, you can see the wavy water surface which acts as the irregular surface, so that the laws of reflection are not obeyed there, so that clear image is not formed in the wavy water surface. It is called diffused or irregular reflection. Now we have to move towards the mirrors. The main topic of our chapter is the mirrors. There are two types of mirrors. Number one are the plane mirrors, also called flat mirrors, and number two are the curved mirrors, also called spherical mirrors. Spherical mirrors are further divided into two types, concave and convex mirrors. Let's see what are plane mirrors. Uh, you can easily recognize a plane mirror whose surface is flat. We use these type of mirrors in our homes, in our daily lives, to see the image. So there are some properties of plane mirrors. You can see here, image formed is a virtual image. In this type of mirrors, the image formed is virtual. It means it is not real image. It cannot be taken on a screen. Object and image are of same size. You can see the image of yourself as the same height as you are. Image is erect and upright. It means the image is straight. Upright means your head is up and the feet are down, means it is not upside down, it is just erect and upright. Image formed is laterally inverted. You can easily see in your image that your right hand appears as the left hand of your image, and your left hand appears as right hand of your image. That is called laterally inverted image. And the last property is both object and image are at same distance from the mirror. When you stand in front of mirror at some distance, the distance of your image will be same inside the mirror as you are in front of the mirror. So these are the plane mirrors. Now spherical mirrors. Spherical mirrors, you can understand from the word spherical that spherical mirrors are the mirrors whose surfaces form a part of a hollow sphere. These spheres can be made of glass or any polished metal surfaces. Means the spherical mirrors are a part of the hollow spheres which are reflecting. Two types of spherical mirrors are concave and convex. These are also used in different fields. You can recognize them according to their uses. Now the curved mirrors, that are convex and concave mirrors. Let's explain these two types of mirrors, the curved or spherical mirrors. As the reflecting surface of these two mirrors is a part of a sphere. Here two spheres are shown. You can see here the convex mirror and concave mirror. Here the brighter portion is reflecting and the brown part, you can see in the figure, it is painted side. It is painted by red lead oxide so that it can become opaque and no light can pass through this part. That's why it is painted by red lead oxide, which makes it opaque. So you can see a curve here. Here this curve, one side is reflecting and the other side is painted. So the reflecting surface is curved outward. If the reflecting surface of a mirror is curved outwards, it is called convex mirror. And in concave mirror, you can see the inner curved surface is reflecting and the outer side is painted. So you can easily recognize these two. You can easily differentiate between these two mirrors, because in convex mirror the outer side is reflecting and in concave mirror the inner side is reflecting. You can also remember this from the word cave, because the cave means ghar, which is inwards. So concave means the inner curved surface is reflecting. So these two types are of spherical mirrors according to their reflecting curved surfaces. Now the parts of spherical mirrors. There are some parts of spherical mirrors you have to understand and remember them before discussing their next characteristics of light and optical instruments. Let's start the parts of these mirrors. Here concave mirror is shown and convex mirror shown. Both of these mirrors have same parts, that's why they are we have to explain them together. You can see the point P, that is called pole. It is the center of the curved surface of the mirror, of the reflecting surface of the mirror, so it is called pole. It is also called vertex. These two names are used for the part. The midpoint of the reflecting surface of the mirror is called pole. It is also called vertex. Next is the center of curvature. Center of curvature, you can see this C is the center of curvature, and it is actually the center of this sphere from which we have taken the concave mirror, convex mirror and concave mirror. So the center of curvature can be defined as the center of sphere from which we have taken the mirror. That is called center of curvature. F is the focal point. The middle point between pole and center of curvature of the mirror is called principal focus. It is also called focal point. In both of the mirrors, you can see F is present between P and C, means pole and center of curvature. That is called the principal focus. If you join the line, join point P and C and extend it, that will become the principal axis of the mirror. Here you can see this line is principal axis of the mirror, and as F is present on the principal axis, that's why it is also called principal focus. The focal point is also called principal focus because it is present on the principal axis. So principal axis is there. One thing more, the radius of curvature R. The radius of curvature is represented by letter R, which is actually the distance between center and pole of the mirror. You can see as radius is the radius of any sphere is actually the distance between center and any of its endpoint. So we can for spherical mirrors we can define the radius of curvature as the distance between center and pole of the mirrors. This distance from C to P or P to C, this is the radius of curvature. In both of these images, in both of these mirrors, you can see this R, and R is actually double of focal length. The relationship between the principal focus, first we have to explain the what is meant by focal length. The focal point is the point between pole and center of curvature. So the distance between pole and focal length is the principal focus is the focal length. The distance between focal point and the pole of the mirror is called focal length, which is represented by capital F represents the point and small f represents the distance, and the radius is actually 2 times of the focal length, or we can say that focal length is half of the radius of curvature. F is represented by R by 2. So you have to keep in mind this relationship between radius of curvature and focal length, which is F equals to R by 2. It means focal length is always half of the radius of curvature. So if radius of curvature is decreased, the focal length will also decrease. It is always half of the radius of curvature. The last thing about the spherical mirrors is the aperture of the mirror. Aperture is actually opening of the mirror. This is the opening of the mirror from which the light rays are incident on the mirror. So aperture of mirror can be explained as the part of mirror exposed to light. It can be less or greater. If the mirror is like this, it is more curved, so its opening will be less, its aperture will be less. This is the aperture. If it is less curved, its aperture will be greater. So the part of mirror exposed to light, or we can say that the part of the part of mirror on which the light can be incident is called the aperture of the mirror, also called opening of the mirror. And the radius of curvature must be greater than the aperture of the mirror. The radius of curvature is this distance from the center of curvature to the pole of the mirror. So this is radius of curvature. It must be larger than the aperture of mirror. So that was all about the parts of the spherical mirrors. In case of any problem, you can ask anything. Further, we will explain the characteristics of these two mirrors. Thank you.